Okay, this is a challenging problem 1. So fx plus gx, the limit is 1, right? Fx minus gx, the limit is 2. Okay, so then the limit of fx, right, plus the limit of gx, it's 1. Right, the limit of fx minus the limit of gx. It is 2. Okay, so this should be 3 over 2, right? This should be negative 1 over 2. Right, you solve it. So the limit of fx times gx, it's the limit of fx times limit of gx. Right, it is 3 over 4. Okay. Part 2, this is a floor function, right? So for example, floor 3.4 is 3. Like floor negative 1.2, it's negative 2. Right? It's the greatest function that is smaller or equal to x. Okay. So first, sketch the region. So for example, floor x plus floor y is 1. So let's say floor x is 0, floor y is 1. Right, floor x is 0, so x is between 0, x is smaller, greater or equal to 0, and strictly smaller than 1. Right, because when x is 1, the floor x is 1. So x has to be strictly smaller than 1. Here, y, floor is 1, so y is greater or equal to 1, smaller than 2. So on the graph, right, x is from 0 to 1, y is from 1 to 2. Okay, so y, this part is included, this part is excluded, this part is excluded, this part is included. So it's this square. Okay, then what about, for example, if floor of x is negative 1, right? Then the floor of y, it must be 2. Right? Floor of x is negative 1, so x is smaller or equal to, okay. So x is strictly greater than negative 2, right? And it's smaller or equal to, x, it should be strictly smaller than 0, greater or equal to negative 2. Right, so strictly smaller than 0 and greater or equal to negative 1. And y, it should be smaller or strictly smaller than 3, right, and greater or equal to 2. So here, y is greater or equal to 2, right, strictly smaller than 3. And x is greater or equal to negative 1, strictly smaller than 0. Okay, strictly smaller than 0. So this is the region. So as you can imagine, you can draw the rest, right? It should be this and this, right? It should be these regions. Okay. Second region, it's floor of x minus floor of y. It's 1, right? Again, you can just draw two parts. For example, floor of x is 1, floor of y is 0, so x is smaller, strictly smaller than 2, greater or equal to 1. Right? Y is strictly smaller than 1, greater or equal to 0. So x is from 1 to 2, x is strictly greater than 1, smaller or equal to 2. Y is strictly greater than 0, smaller or equal to 1. Right, so it's this part. So let's try another. What about x is 2? Right, x is 2, y is 1. So x is strictly smaller than 3, greater or equal to 2. Y is strictly smaller than 2, greater or equal to 1. Right. So it should be x is strictly greater than 2, x is greater or equal to 2, strictly smaller than 3. Y is greater or equal to 1, strictly smaller than 2. Right. So it should be this part. So the rest, right, it should be this. Here it should be this, right, extra. Okay. Then what's the limit of flaw of x over x? Right. So flaw of x, as you can see, flaw of x, it's always smaller or equal to x, right? But it's strictly greater than x minus 1. Okay, it's strictly greater than x minus 1. So we can use the squeeze theorem, right? And what about the limit of the left? It is 1. What about the limit of the right? It is also 1, right? Then by the squeeze theorem, the limit of this part, it's also 1.